Hey guys, welcome back. Today I am super excited to be bringing y'all this video because this is my first Forged Hunter. Now this build took me a long time to do because I tried a ton of new things, so I hope that y'all enjoy the ups and downs of this project, and I'll pass it off to my normal narration. So yeah, this is something I've been wanting to do for a long time, that is forging a knife, especially a hidden tang knife, and I've been looking up to some greats like Kyle Royer and Nick Wheeler, watching their work, and it really inspired me to try forging some knives myself. So I had the time and the steel, so I've decided to get to it. The first thing you saw me doing there was creating a template out of wood of what I want the knife to look like, or at least a shape that I want the knife to look close to. Realize that I am truly a novice when it comes to forging a blade, so the things you see me do here may not be the most efficient. I take a lot of heats to get this blade to the shape that I feel is good enough to start grinding on. What you notice me doing here is starting to forge in my bevels. I'm bringing the blade to the edge of the anvil and hitting it with some glancing blows with the hammer coming off the anvil. This is drawing my bevels in, and also it is adding some curvature to the blade towards the tip there, and that is why you see me trying to get it straight and back out. You'll notice this anvil here has had some years on it. This is actually my grandfather's anvil that he bought in the port of New Orleans about 100 years ago. So pretty cool history to be forging a knife on my grandfather's anvil. That just makes me happy. What you just saw me do there was hot cut off of the extra material and then start using the tongs to flip this knife around and start forging out the tang. I was actually able to utilize the cross peen on this hammer to get that work done a little faster. I'm so inefficient with my forging that this really wore me out forging this blade. I actually forged two of them just in case I mess one up. So I have another one that I'll probably finish out later on, but it really wore me out this day forging out this knife. And my hammer technique's probably not great, and it definitely took a lot of heats to get there, but I just put it in vermiculite there so that it can cool slowly and anneal, so to speak, over the course of the next few hours. And by the time I take it out, it was around 290, 300 degrees Fahrenheit. This ensures that the blade will be soft enough to drill and probably easier to grind as well. That thick forge scale that you see on the knife there is pretty rough on belts, so I took my angle grinder to it to knock the bulk of it off before sacrificing my expensive belts on it. I just wanted to note that this blade steel is 1084, and I started off with a 1/4 inch by 1 inch wide piece. So now we're getting the rough profile put in this knife. Before I surface ground it, I wanted to profile it a little bit on a worn ceramic belt, and then also maybe roughen the bevels just slightly here. I'm practicing this work rest push stick grinding technique, and I saw a bunch of really good knife makers using this technique, including Travis Wirtz, who manufactures the TW90 grinder, and Nick Wheeler. Both of them I've seen use this work rest technique, and I think they learned it from a gentleman named Tim Hancock, who was a mastersmith. So with a laundry list of excellent blade makers utilizing this technique, I figure it was time for me to give it a go. So now that I have the bevels rough ground in and the profile of the knife roughed in, I set up my surface grinding attachment so that I can get the ricasso area and the tang all surface ground flat. This really didn't take too long. I used a 120 grit 3x79 inch combat abrasive shredder belt there, and it did a great job. So now that I have both sides of the blade flat, I wanted to true up the top of my blade along the spine. This area will be used to be mirrored when I am trying to get the ricasso nice and square with itself. So I took a good deal of time there to make sure that the ricasso area on the side is square to the top of the spine. And then back to the belt sander to get some bevels rough ground in here before heat treating. I'm using a 120 grit J-Flex Hermes belt just to get everything kind of close, not even really close to the final dimensions, but maybe 70% of the way there before heat treating the blade. I think the edge of this blade is around 40 thousandths of an inch, maybe 45 thousandths, so it's pretty thick there. So now that the spine at the top of the ricasso and then both of the flats of the ricasso are square to each other, they will be reference points moving further into this build. I'm going to jump in real quick here, guys, to ask a favor of y'all. If you have any friends with beards, please share this video in their direction. I'm sure they'll appreciate the video and probably respect you more for doing so. Also, if you have friends without beards, I'm sure they'll like it too. Alrighty, so back to the hand sanding here. I'm just cleaning up the bottom of the ricasso and the choil there between the ricasso and the edge bevel. I just want to get all of the surfaces up to a fairly fine grit, maybe a 320 grit finish, to make my life easier moving forward after the heat treat. Using a square with the top of the ricasso, I was able to scribe a line to help me line up my file guide. This is actually the second time I'm using this file guide. This is a DIY carbide insert file guide that I made recently, and if it works as it should, I'll be making a build video on this file guide. This carbide's pretty darn tough. The files didn't even get close to cutting into it, and then I eventually used my 2x72 belt sander, and the belts on there didn't do anything to it either, both the ceramic belts and the normal aluminum oxide belts. So what you can see me doing here is I'm actually filing away a little bit of the sides of the tang so that the guard will be able to fit over that ricasso on the sides, and you'll never see any daylight. I've actually seen this done both ways, where the sides of the tang are not taken in during this step, and I think Carl Anderson would be a good example of someone who's been able to have a lot of good success without doing that step. So I think in the future builds, I'll try it the other way and see how it works for me too. I definitely fiddled around with these steps probably longer than I needed to, just because this is one of the first times that I've done a hidden tang knife like this. I really didn't want to mess it up. I actually came back later after the heat treat and softened the tang and fiddled with it a little more, so it took me a while to get this the way that I liked it, but in the future I bet I'll be able to do it much faster. I'm actually putting 2 shoulders in here, and I'll explain why I did that in a moment. And then when I have an idea of how long my handle will be, I'm cutting off the excess tang. Alrighty, so this is what the knife looks like pre-heat treat. We have the profile rough ground in, as well as the bevels. We have about a 40 thousandths thickness at the edge here. The profile is going to be modified a little bit. I don't like how it hangs down low here. I want this to be straighter, so we're going to fix that after the heat treat. I also have my shoulders filed in here. This first set of shoulders will be for the guard, and the second set of shoulders is to maximize the amount of wood that is being wrapped around our tang. I was a little nervous about this thickness here. This seemed pretty thin to me, and I asked a question on Blade Forums about a rule of thumb, and I was directed to Carl Anderson's page where he does this double shoulder design, so I promptly stood on the shoulders of giants and stole that from him. So the next step here is to heat treat this blade, and then we can get to prettying it up a little bit. There are a lot of components of this build that I'm doing for the first time, but happily when it comes to heat treating 1084, I have that down pat. While the forge is heating up, I went ahead and drilled my hole in the tang. This hole will be accepting an 1/8 of an inch pin through the handle material. Notice I drilled a 1/4 inch hole, and that is because I will be putting a brass plug in that hole as a target to drill into, a soft target, when I am affixing the handle to this blade. Since this is a forged blade, I did 2 normalizing cycles, and then on my 3rd heating cycle is when I quench the blade. This takes a little extra time, but it ensures that you de-stress the blade and also prevents some major warping. So I quench the blade into Parks 50 for about 4 to 5 seconds, and then get it into my straightening jig here, which will allow the blade to cool straight. So far, this set of straightening plates has not failed me, and I'm super happy about that. This blade came out nice and straight, and it was also very hard, which I verified with a chainsaw file. Before putting this quenched hard blade into a tempering oven, I clamped it between 2 pieces of angle iron and this is in an effort to stop the blade from shifting at all during the tempering process. I'll be doing 2 tempering cycles at around 214 degrees Celsius that both last 2 hours long. You can see there I ended up taking the top off of my PID controller. My garage was running at about 95 degrees, and I felt like the PID controller needed a little help. So I put a fan on it and took the top off. Alrighty guys, so the heat treat was successful. The knife came out hard and straight. So our next steps is to clean this knife up a little bit on the belt sander and try to get the bevels ground in and get everything roughed out to around maybe 320 grit before moving on to the other operations. We'll take this opportunity now to clean up the area where the blade starts. If you remember, I mentioned that I felt like that hung down a little too low and I wanted to straighten it out, so that's what we were doing there. And then we got the surface grinder attachment back out to get the flats of this blade around a 360 degree gator belt finish. I've been using this darn surface grinder more and more lately, and I'm super happy I built this thing. Now that one side is done, I'm going to put a layer of masking tape over one side to protect it from the magnetic chuck. If you don't do this, you'll get some scratches on that side when you try taking it off of this chuck. So we got one side done, get the other side done, and this is how they came out. This is around a, actually I think it's more like a 220 grit gator belt finish there. I'm bringing the spine of the knife up to a 320 Rhino Wet paper finish here, and then we'll also get the choil area at the bottom of the ricasso to the same finish. We'll get a little marking fluid along where our edge is going to be on this knife, and then use this height scribe with a carbide tip scribe in it to mark off our center line. I like using this height scribe to do this because I can go back to it easily during the grinding process and remark that line. I think during the grinding of these bevels I actually remarked that line about 3 times. It gets a little faint as you get going, and I just like having a very nice visual target to grind to. We're starting off with a VSM 60 grit ceramic belt here to get them roughed in. After the 60 grit ceramic, we'll move on to a 120 grit J-Flex belt, and that will allow me to radius the plunges a little bit, and that's when I actually start focusing on getting those plunges lined up. So like I said, we're remarking the edge here just to make that target nice and prominent. I actually did a really good job grinding these bevels in my opinion. They were really nice and clean and straight and symmetrical. I had a little bit of meat towards the beginning of the edge in the plunge area, but I was really happy with them. To maximize the visibility of my third edge target here, I put some angled scratch marks in the edge of the blade with 320 grit sandpaper. And then I took a very close visual look to kind of figure out where I need to go for the rest of the bevels here. Where the thickest parts of the edge were and where the thinnest parts were. I really like these Hermes belts. They leave a really good finish and they're extremely flexible, and that's what I'm looking for in a J-Flex belt. So now we're going to tape up the blade so as not to damage it when I clamp it in the vise, and we're going to glue back the tang of the knife to soften the tang. I bring that color all the way in to the ricasso just so I have the straw about halfway through the ricasso there. This will give it, I think, a little bit of a spring temper in that area and just toughen up the knife in general. Softening up the tang also gave me the opportunity to fiddle around with these shoulders a little more. I'm not saying this is necessary in any regard, it's just I wanted to make sure they were dead on. I'm measuring here to make sure that the tang has a slight taper towards the end there, and it does. Alright guys, so the grinding and the bevels of this knife went really well. I was able to get them very lined up, very symmetrical, and I'm pretty proud of them. However, if you look really close and put a straight edge on them, they're not 100% straight on both sides. That's the plunge line on both sides of the knife. So I'm going to try out a method that I saw Kyle Royer use, which is to create a top platen on his grinder and attach a file guide on it to the knife to get both sides perfectly straight and perfectly symmetrical. So I'll either end with perfectly symmetrical plunges or I'll completely jack up this knife. So we're about to find out. So yeah, this is a new method for me for trying to get the plunge lines perfectly in line with each other. To be honest, they were pretty darn good starting off, so I don't really think this was a necessary step for this knife, but every once in a while I get them a little off-centered and I want to try something new. There's a lot of friction on this setup going over the top of this platen across that edge. I put a slight radius on the front edge of this jig, and that radius will be matched on both sides of my plunges. When setting up your file guide on your plunges, this is actually a little too close. You want that file guide off of the plunges a little bit to give that radius at the top of your top platen a little bit of space. I ended up changing this, and I'm not sure if I showed it on video or not. Also, it's worth noting I stood off to the side of this system because I was slightly leery of it, and I think you should be leery of a top platen system like this. The last thing you would want to happen would be for the belt to grab the tip of this blade and throw the whole thing. Now, I don't feel like I even got close to this happening to me. It never felt grabby, but it's just something to be cautious about. I would definitely not use a cork belt or a surface conditioning belt in this orientation because those things are extremely grabby. So, slow belt speed and very low pressure to do this operation. And this actually took a really long time, but I think the results were fairly good. It's going to take a little practice with this setup and using the file guide and whatnot, but I think the plunges came out pretty good in this case. You'll notice that I have a little bit of meat there in that spot, so I actually grind back the ricasso a little bit longer to get the edge at the beginning of the plunges a little thinner. So that was kind of my workaround there, and you'll see me, actually you won't see me do this because I put this light right in the way of the camera by accident. So that's what it looks like after doing that. And like I said, it came out pretty good. Very symmetrical plunges there, and I think I will mess around with that contraption again in the future for sure. Now that we have our plunges dialed in, we'll go over to the knife vise and start hand sanding. I'm going to be bringing up this entire blade to a 320 grit hand sanded finish. I have a pro tip for you guys when hand sanding. If you ever feel like you are finished, just think that Nick Wheeler is standing over your shoulder looking at your work, and you'll hand sand for about another hour for sure every time. I used a hard backer for the majority of this hand sanding, and then my finishing strokes are using a soft rubber backer just to kind of keep everything nice and smooth on my final strokes. Then using another hard backer, I took a 320 grit piece of sandpaper and cleaned up the bottom of the ricasso. This area will obviously be very difficult to get to after the guard is fitted and the handle is on the knife. So I'll be using a 1/4 inch piece of stainless steel for my guard. I think I probably could have gone with a slightly thicker piece of stainless, but this is the piece I ordered and it turned out looking pretty good. I cut a 1.5 by 1.5 square, which after thinking about it now is way too big. I didn't need to cut off that large of a piece. You may have also noticed that I used a handsaw to cut off that stainless. It's because the blades of my bandsaw were dull and I didn't have any replacements. So using some 1-2-3 blocks, I set up a very rudimentary fence here so that I can get all the sides nice and square with each other. This is kind of a preliminary step because I will be milling these sides flat. And then surface grinding attachment comes in handy again to get both sides nice and flat with each other. This first pass I made with a very dull 1/2 inch end mill, and then the second pass I made with a new end mill, and the difference is night and day. I got a way better finish on the second pass. So now I have a nice square flat piece of guard material here. So we're going to mark off the center line of this guard material, and then we're going to do a little bit of math to figure out the slot size and mark that off as well with these calipers. I'm measuring the width of the tang, and then the width of my ricasso is actually a little wider. So to make it easy on myself, I'm going to use an 1/8 of an inch end mill. To mark off where my slot will be on the guard material, we'll take the total width of the piece minus the 1/8 of an inch end mill, and then divide that by 2 to get our Y value, set our calipers to that value, and then scribe the sidelines of our slot. And then we can do the same thing for the top and the bottom side of our slot there. I'm using an 1/8 of an inch spotting bit here to make sure that my vise is nice and in line, and then I am at the center line of this piece. I'll then change out the drill chuck with a 1/8 of an inch end mill inside of an R8 taper. And like an idiot, I did not clamp down the piece, and I kind of ruined the surface finish there, which I'll go back and finish with the surface grinder later and clean that up, but I was pretty pissed at myself for doing that. Once I get to one side of the slot, I will set these stops on my mill so that I know where the top and the bottom of that slot is. You also saw me use a plunge cutting technique that I picked up from Carl Anderson. And if you guys have any other recommendations on how to do this, I'm all ears. All the machinist guys who are out there, I'd love to hear your technique. This worked pretty good. I'm just open to a bunch of different techniques here because I want to try a few new things. But like I said, Carl Anderson's technique here was excellent. It got the job done. It just took a little bit of time, and my mill isn't really set up very well for plunge cutting with that very weak torsion arm. I need to upgrade it to an air system eventually. So in short order, on the surface grinding attachment, I was able to erase our mishap on the vise there, get the surfaces nice and flat again, and then I marked off the inside top of the guard just so I can keep the orientation the same whenever I'm trying to fit it. I'm actually making a tool here. This is a piece of 1084, and I'm going to be using it as the backing plate to the guard so that I can hammer on this and not worry about messing up the finish of the guard, and also I can apply the pressure of my hammering to the whole guard face. So I heat treated it and then I tempered it to straw so that it's nice and hard but soft, soft enough to be able to take hammer blows. To protect the blade during the guard fitting, I wrapped it in some magazine paper that's been coated with lubricant, and then I started off on the guard by squaring up the shoulders since the mill leaves a radius there on the slot. Once I have the shoulders square, I placed the guard onto the knife and then tapped on it a little bit with the hammer so that I can get an indent or some indication of where the ricasso is hitting on the guard. Then using a Kyle Royer method, I took some diamond impregnated tips on my die grinder and started removing material where both of the shoulders are impacting the guard. This is done in order to recess the ricasso into the guard just a little bit, maybe 10/1000ths, and remove gaps like you see here. So what you'll do is you'll take away a little bit where the shoulder's hitting, coat it with a Sharpie, hammer it onto the knife again, and then go back and forth, removing material until the guard fits up over the ricasso. This method, while time-consuming, actually worked out pretty good for me, and I was able to achieve a very nice guard fit that you can't see any daylight in. So I'll definitely do it again. I think I'll be able to do it faster the next time around, but you just got to be really careful when you're sitting there with the Dremel tool. It wants to walk on you every once in a while, and you can really mess up your guard. In this step, we are peening a brass plug into the tang. I'm doing this so as to have a target whenever we drill the pin through our handle material. I want it to impact a soft material so that it drills through it easily, doesn't create excess heat, and doesn't allow the drill bit to walk. So with a Sharpie, I lined up where my maker's mark should go based on the shoulders of the tang, and then I etched in with DC power about 12 or 13 times with my etching machine to get a nice deep etch. After I have a nice deep etch, I'm trying out this brass black, another Kyle Royer trick. We're going to brass black our maker's mark so that the valleys of our mark are nice and dark. So once your mark is etched, you just put a little bit of this brass black over it. It gets into the valleys there, makes them nice and dark, and then you clean it up with a little sandpaper afterwards. So that worked out really good. I think in the future I may be able to do this 1 or 2 times and make it even darker, but I was pretty happy with the results this time around. I'm going to be using a piece of Purple Heart for the handle. To get an idea of the excess that I can cut off, I cut out my drawing of the handle, and I also marked off where my tang is going to be, and this is going to help me down the road get an idea of where to drill. Using an 1/8 of an inch drill bit, I drill 3 holes in the face of the handle so that I can start making a slot. I can't do this on my mini mill since there's not enough space, not enough throw between the chuck and the table. So the Win drill press, the cheapo drill press, is coming through in the clutch. Once I get the holes drilled, I will use the drill bit to connect those holes together. I actually ended up enlarging these holes to a number 12 bit size. Once I got these holes preliminarily drilled, I was able to use my new handle broach to square up the slot and also remove the additional material needed to get a nice fit on my tang. We're squaring up the work rest here so that I can grind my guard to shape. I used a template to try to get both sides of the guard symmetrical, and you can see my scribed lines there, but with the amount of grinding I ended up doing on the handle down the road, it made this part unnecessary. Using the radius of the wheel, I started my curvature at the bottom of the guard. This is going to be in the finger choil. I think this is a 1-inch wheel with a 60 grit ceramic belt there. I made sure that the front of the handle material is flat, and then I test fit the whole assembly here so that I'm not running into any surprises during my glue up. So like all glue ups, the first step is to make sure all of your surfaces are clean. I'm using alcohol for this function. You don't want any oils to affect the adhesion of the epoxy. I put a little bit of epoxy on the tang and then slide the guard on. Then I have a G10 spacer that I'll be putting on in between the guard and the handle material. I did this just because I thought it would look cool. No other reason there. And then I poured the rest of my epoxy into the handle slot and then forced that tang in there slowly to make sure that any air bubbles come out. Then using a clamp and a piece of wood, I get this thing straight and clamped up. I had a little bit of excess epoxy in the front of the guard after sliding it on the tang that already had epoxy on it, so I cleaned that up and then left this overnight to dry. So today we're going to be taking this block of wood and turning it into a handle. Now I don't have a ton of experience with creative bottle shape handles, so I'm going to give that a go today. I've done it one other time, and that was with my handle broach just for practice. So I'm going to try some nice fancy grinding on this handle. Also, I don't really like the way my guard is currently shaped, so I'm going to see if I can correct that on the grinder so it looks a little bit more natural. I'm still trying to get a good idea of how these hunters are designed from the handle side and what proportions look good, and I'm sure this one won't be 100% right, but as I go, I hope to refine what my hunters look like. So let's get started with the grinding. So before we start grinding, I use that spotting drill again to spot where my hole will be for the pin, and then I drill an 1/8 of an inch hole into my handle through the brass plug that's in my tang. You can see there I started getting some brass back, which makes me happy. It means that I definitely contacted that plug. You can also see that my 1/8 of an inch drill bit has a little bit of run out on it, so one side of the knife, the hole is just ever so slightly larger than the other, and I compensate for that later on by tapering that stainless steel pin that I put into that hole so that it has a nice tight fit on both sides of the handle. Once that drilling operation is done, I go to a 60 grit ceramic belt and start shaping this handle. I take down the front towards the guard first to get the tapers there, and then I move on to my 2-inch contact wheel to start bringing in the curves on the side of the handle. When I was doing the finger choil area in the front of the knife, I actually went deeper than I planned to. You can see that right here. There's a little bit of a finger choil here in the front, and it didn't end up being an issue, but it did, in my opinion, probably weaken that area of the knife because it got closer to the tang than I wanted it to be. So in the future, I'll be very careful when utilizing a small wheel attachment in that area of the knife. Surprisingly enough, shaping the handle with this 2-inch wheel is not that difficult, or I found it not too difficult to get the shape that I wanted. I think in the future, though, I can make the radius bigger on the butt end of the knife. I can make that radius bigger by moving it more, not necessarily by having a bigger wheel. But in my case, I feel like that radius was just ever so slightly too small, and I think I can improve that on my next Coke bottle handle. After getting the bulk of the handle shaping done, I figured it's time to put this pin in. This is that slightly tapered pin, stainless steel pin that will get epoxied into our handle here. Once I gave it some time to dry, which in this case was actually overnight, I cleaned up the ends of that pin on the belt sander and then finished off cleaning them up with some hand sanding. To make sure that those pins are not domed, I use a piece of hard backing, which is actually a little piece of metal here, behind my sandpaper so that it stays nice and flat and there's no doming on that pin. I also made sure to use a hard backing for my sandpaper in the transition between the guard and the handle material because I don't want a little dip there from the sandpaper eating away the handle material faster than the guard. So this took a very good deal of time here because I wanted to make sure that my scratches were all going in the same direction on the guard, and I wanted to bring the handle up to around 1,000 grit finish. My progression on the grits started at a 320 grit sandpaper. I moved to a 600 after that, and then finally a 1000 grit paper. On the 1000 grit paper, I started using my hands and fingers more than the hard backings, and I wasn't really taking away that material, so I didn't see any problems with doing so. I'll make sure I put a good coating of lubricant on the blade just so I don't have any problems rusting, because I'll be using a water-cooled sharpener to put the edge on. This wind sharpener has been working out pretty good for me. The only issues I've ever had with it are on blades that don't have a sharpening choil and the plunges are at the beginning of the edge. In this case, that's not an issue since the edge actually hangs lower than the ricasso, so it's actually a very convenient sharpener for this style of knife. It's funny, after doing the review on this sharpening system, people ask me about this thing all the time, and all I tell them is, yeah, I'm still using it, the machine's still working, and it still puts an edge on a knife pretty quick. So far, no complaints there. So as far as my first forged Hidden Tang Hunter goes, I feel like things turned out pretty good, or at least they did in my opinion. There are, however, some flaws in this knife, or things that I feel like are flaws, and I'm going to point them out here. First of all, I feel like the handle is a little thicker than I would like when looking at the knife from above. In the future, I plan on making it a little sleeker in its design and also making the radiuses of the Coke bottle handle slightly larger than I did. As far as the guard fit up goes, I feel like the fit up is pretty good. When looking across the knife with a light source behind, you will not see any gaps in that guard because it is recessed over the ricasso. There is one issue with the guard fit, and it is that I milled the slot just a little too wide in relation to the thickness of the ricasso. It's very hard to notice, but if you look hard enough, you can see a slight shadow between the guard and the ricasso, and I don't like that, and I will fix that in the future. Lastly, I feel like the ratio between the length of the ricasso and the width of the blade is slightly off, and this is something else that I'll have to work on in the future. In the case of this knife, I feel like the ricasso is just a little bit too long. So I hope you guys enjoyed watching this build as much as I did building it. If you liked this video, please hit that like button down below and consider subscribing to the channel. Until the next time, I'll catch y'all on the flip side.